Hello students, welcome to Studi.Live. So today we are going to talk about mechanical properties of fluids. Your exams are also very close by, isn't it? So you must be worried how to revise in a short time. So this is what we have started with here. So in 40-45 minutes you are going to revise the whole chapter, students. Okay, let us talk about mechanical properties of fluids. Now in this we are going to talk about two concepts. One is about the fluid, okay, and the next one we are going to talk about surface tension. Okay, so these two topics we are going to learn in this chapter. So you can just consider that properties of fluids may be of 3 marks and surface tension may be of 4 marks. This is how the weightage will be here. Now let us talk about the first thing. So students, we are going to talk about the fluids. Of course, fluids is a substance, okay, that deforms continually under the action of external force. This is what the meaning of fluid here. And then we have to study about the properties of fluids. You should learn this particular part. So there are 3 properties are given which you have to learn about. So at least just for 1 or 2 marks you have to study for this particular topic. And then we are going to talk about a very important concept, that is pressure. So in this case, students, you should know about the definition of pressure. Of course, it is force upon area. And then we are going to talk about all these concepts you have to study, students. Okay, that is the units, dimensions and conversion, everything you have to learn about. Okay, so 1 bar is equal to 10 raised to 5 Newton per meter square. And 1 hectopascal is 100 pascal. So this conversion you remember, students. Of course, in MCQs you will be asked. And then after this, then we are going to talk about the pressure due to liquid column. Now in this case, pressure due to liquid column, of course, when the liquid column is there, what is the amount of pressure which is acting on it, students? So this is the derivation part, that is the force is equal to force upon area, where force is equal to mg upon A, and then you are going to substitute everything. Of course, m meaning is nothing but what? Volume into density. So this, after substituting, students, we are going to get here P is equal to H rho G, that is the height, density and G value. Okay. Now in this case, this particular formula you have to remember, this is another part of pressure formula. And of course, as I told you, every time I tell you that you should always solve examples. Okay, solve examples, questions are all important in the numericals part, students. And then we are going to talk about the absolute pressure. Absolute pressure, as you can see here, look at this. Here F1 is the pressure which is in the downward direction, F2 is the pressure which is in the upward direction, and the height of the liquid column is x1 minus x2. After knowing all these things, so we get the F2. That is, upward pressure will be what? Downward pressure and mg. Okay. Now in this case, there will be atmospheric pressure. That atmospheric pressure is taken as what? P naught. Okay. So the total pressure which is acting on the liquid column is what? P is equal to P naught plus H rho G. Okay, students. So this also is very important formula. So whenever liquid column question is there, so you have to apply this particular formula, right? And where H is nothing but the difference between the two levels, right? X1 minus X2, that is the height of the column, we can say. Then after this, learning about that part, students, we are going to talk about the important concept again here. This is all 2 marks question will be asked, that is the hydrostatic paradox. So what is the meaning of hydrostatic paradox, students, here? Now as you can see in this particular diagram, different vessels are given of different shapes, right? That means here it is shown that different vessels having different base, but the height of the liquid column, you can see, height of the liquid column is same, right? That means this is what is explained in hydrostatic paradox. That means the liquid column, height of the liquid column does not depend on the shape of the vessel. This is what is explained over here. And then comes the Pascal law. Pascal law, students, you have to learn this part. This is an important one. And Pascal law says that, again in this case, in case of Pascal law says that the pressure applied at any point in an enclosed fluid, okay, transmits the equal pressure at every point and even on the walls of container, right? Then these are the applications, students. Okay, first is hydraulic lift. Hydraulic lift, everybody must have seen that for washing car and everything, we use that particular hydraulic lift. As you can see here, the 2 containers are there, one is big and one is small. In the small one, when you apply less pressure, okay, so what happens, the result is very high pressure which is given to that, and here the car or any object which is heavy object is placed here, so small force and you get what? Large pressure which is applied on that. Because of that we can do all that. So this is nothing but the piston work is happening over here. Okay, so this is what the concept is, and in this case the pressure, as Pascal law says, that the pressure is always equal at any walls of the container or any place. Okay, so that concept we are going to use. Based on that, students, we are going to get this formula, because we know that pressure is nothing but what? Force is pressure into area, or pressure is force upon area. Based on that, we are getting this particular formula. Okay, so remember this is a very important formula. Okay, then comes the hydraulic brakes. Hydraulic brakes again is also very important one, and that is used in all this heavy vehicles and everything, and this is the very proper and good brakes, we can say. There are two types of brakes: disc brake, which is normally used and it is less expensive, disc brake, but is not very, performance is not very good. But hydraulic brakes performance is really very good, and it is little heavy, expensive, we can say. So it is used in aeroplane, cars and cranes, everywhere this hydraulic brakes is used. So this is the concept, students. When the brake is applied, brake pedal, when the brake is applied, as you can see, here the piston size area is small. So that gives small brake application will give you what? Very good result for the brake here. So this brake fluids, okay, that gives what? Opposite direction rotation of the wheel. Because of that, it stops, wheel stops. That is what the concept is. So remember this particular two concept applications of Pascal law. And after this, of course, the formula is same, that is F2 is equal to F1 A2 upon A1. Again, students, as I told you, numericals, you should not forget about it. And then measurement of pressure we are going to talk about. So students, measurement of pressure, of course, is what? Pressure gauge or vacuum gauge, we say. Okay. Now, in this case, again, the measurement for that, two concepts are there. So one is mercury barometer and the other one is open tube manometer. Both the concept is very simple. You have to study about, maybe short notes or questions can be asked in that. Okay. This particular you have to study about in detail. If any doubt, students, definitely you can put it in the comments so that we can explain in detail about it. Since it is a quick revision, so I am telling you which all important parts are there which you have to remember. In both the cases, as you can observe here, that the pressure, that is which law we are applying here, Pascal's law we are applying here, the pressure is equal at two different places. This is what the formula we can use for mercury barometer, students, in this case. And for open tube manometer, again the same particular formula only, because pressure is equal to atmospheric pressure plus bottom pressure, that is H rho G, we have to apply that particular part. So this is all about the properties of fluids we have learned here. Now the important one is about surface tension. So surface tension, students, you know what is the meaning of surface tension. You must have seen that if the water is still, right? So insects walk on that because of surface tension on the water level, right? So how that is produced, that everything in detail we are going to see that. This is a very interesting topic. Now in this case, students, we can see that because the nature of the liquid water is to occupy less area. That is why it is always spherical in shape. Even raindrop is what is spherical in shape, because it is the nature of the liquid that it will always occupy small area, small volume. Okay. So first concept we are going to talk about is, that is molecular theory of surface tension. Now in molecular theory, students, few definitions are there which you should know, that is intermolecular forces. Of course, intermolecular forces, as the name suggests, is the force between two molecules, right? Force between two molecules is called as what? Intermolecular force. Now again, there are two things in intermolecular force. One is cohesive force and one is adhesive force. Now cohesive force, of course, between the same molecule, okay, between two molecules of the same substance, we can say, and adhesive force between two molecules of different substance. For this particular example, very simple, chalk and board. Right, chalk and board is what? Which force is there? Adhesive force, because chalk is of different material, board is of different material. But at the same time, cohesive force, if you want to understand, we can, simple example we can take water droplets. Water inside water droplets, between the two water droplets, which force is acting, students? That is the cohesive force. Okay. Then you have to learn about these three definitions. Don't forget to learn these definitions. That is the range of molecular force. Range of molecular force, of course, if there is a molecule, students, and this is a imaginary surface. Okay, this particular imaginary surface we call it as what? Sphere of influence. And this radius we call it as what? Range of molecular force. So here molecule is at center, this is the molecule, and the radius we of course we call it as what? Range, and the imaginary sphere we call it as what? Sphere of influence. The surface film, the surface layer of the liquid with the thickness equal to the range is called as what? Surface film. So this is all the concept you have to remember. Remember the definition of it. Of course, here as you can see in particular diagram, just to understand this, there are three molecules, water molecules are taken here, A, B and C. You can observe that molecule A is very well inside the water. That means equal forces are acting on that molecule A, and because of that what is happening is net force acting on the molecule A is 0, because from all the sides it is acting. As you can see in case of B, students, the one part which is above the water liquid, which force is acting there? Adhesive force, and inside it is cohesive force. Of course, cohesive force is more, so it will try to bring it down. And in this case, you can see C molecule, half of the adhesive force is acting, half of the cohesive force is acting. So here again, the more weight of the body is which is inside the water, so the molecule will be brought downward. Okay, so because of that there is a small film is created which we call it as what? Surface tension. Then after this we are going to talk about, so this is all we are going to study about the molecules. It is given here molecule A, okay, molecule A, molecule B and molecule C. It is explanation is given, you can just read it once, okay. So you will understand the concept here. Then comes the surface tension formula. Surface tension formula, at least minimum this much formula you have to learn, that is the tangential force. Surface tension is nothing but tangential force acting per unit length. Okay, so T is equal to F upon L. So this particular dimensions, remember students, of course surface tension unit is Newton per meter. Then comes the surface energy. Surface energy is nothing but what? Surface tension into change in area. So to understand the surface energy, this particular derivation you have to remember. In this there is a rectangular frame. This is a rectangular frame which is considered, and there is a wire which is there, which is movable, which can be moved in and out. So the forces can be act because of moving in and out, area will be changed. So that concept is used here. Okay, if we talk about only length, is here F is equal to what? T into 2L, because two sides of the length we are going to consider here, and of course this is based on T is equal to F by L we are getting. To derive this particular part, so what is the work done? Force into displacement. So work force is what? T into 2L. Just now we have seen that into dx, right? So we get the surface energy formula as T into dA. That is the change in area. Again, as I told you, numericals, very good questions are given here. So you have to use that part. Then comes the important concept, students, angle of contact. Don't forget to learn this. This is a very important concept. Questions definitely will be based on this. So for angle of contact, you have to learn the definition of angle of contact, students. Okay, so angle of contact is defined as the angle between tangents drawn to the free surface to the liquid and the surface of the solid inside the liquid, within the liquid. Okay, this particular part, as you can see, this is the angle of contact which is given. Okay, then the definition you learn, and then comes the different shapes of meniscus. Based on meniscus, we can decide the angle of contact. If it is concave meniscus, okay, then the acute angle. What do you mean by concave meniscus, students? You have seen that the water level, okay, this is the concave meniscus, okay, this particular part. If like this, if the meniscus is there, that means we can say that the angle of contact is acute. And if it is convex meniscus, and that usually happens in mercury, you can see the convex, like this meniscus is there, that means the obtuse angle of contact. So based on all this, we can definitely decide the angle of contact. Okay, and then comes the here zero angle of contact, students. Zero angle of contact, we can have it for the pure water which does not have any impurity. For the pure water, we get zero angle of contact. That means the surface of the water will be straight. Okay, so this is the zero angle of contact, students. And then comes the angle of contact which is 90 degree, and the conditions for that. So 90 degree, little bit hypothetical liquid we have it, it doesn't exist much, but we can definitely learn the one point here, because in this case the net cohesive force is at 45 degree. Remember this particular concept. So students, after this comes the different shapes and all is given here. So based this different shapes of that, this is a mercury, that is a convex, and then liquid form is there. So what happens? What are forces act on that? That is tension acts on that. This is what is explained over here. If this is the case, students, that means T2 is greater than T1. Okay. Again, in this case, like that, you have to just understand this concept here, this formula. Remember this formula. Okay. These 4 conditions you have to remember. And then factors affecting the angle of contact, very, very important point. Okay, so 2 marks or 1 mark, definitely question will be there. What are the factors, students? The nature of the liquid and solid, it depends on that. Impurity, if it is added, the angle of contact will change, and if it is liquid is heated, of course the angle of contact also will change. Okay, so these are the conditions, factors which is affecting over it. Then comes the effect of impurities. So what happens when the impurities are added, students, here? Then that will affect the surface tension of water. If more impurities, then in this case what will happen? The surface tension will decrease if the impurities increases. This is what the point is. Just learn 2 lines at least. Okay, so effect of impurities, in short, we can remember. Okay, so that means we can say that surface tension of the water decreases. Okay, so because removes the stains and all. That is what the reason here given when you add detergent to it. Okay, then based on this, next one is effect of temperature. So which are different factors? Effect of impurities, effect of temperature, everything you have to include this. As temperature increases, students, the surface tension, okay, decreases. Okay, so this concept you have to remember. Then in this case, what else is important to learn is excess pressure formula. Okay, excess pressure formula, this is the derivation. Okay, excess pressure formula, as you can see, this derivation is very, very important. Okay, 3 marks question can be asked. And for excess pressure formula, of course, if you take a liquid drop, inside pressure and outside pressure, Pi is the inside pressure, Po is the outside pressure. Okay, that excess pressure, of course, which will be greater. So inside pressure will be greater, then only it will be like this. If outside pressure is more, of course, the liquid drop will not remain in that particular shape. So it is Pi minus P naught we have to calculate. And of course, this is the radius of the liquid drop, and this is the extra part, that is the delta R, which is given here. So based on that, as we have studied that work done is nothing but what? Surface tension into change in area. So we are going to find out change in area first, that is A2 minus A1. This is the A2 part we have got, and this is the A1. That surface area formula we know, students, it is 4 pi r square, and if it is increased, of course, with the delta r, so we are substituting this. So dA part you are getting what? 8 pi r delta r. You can just write once, you will definitely understand this particular part. It is not that very difficult. Then we got this energy, surface energy, as what? T into 8 pi r into delta r. And then after that, of course, this particular formula. So pressure is nothing but what? Force is what? Pressure into area. So pressure is, of course, axis pressure. So Pi minus P naught into 4 pi r square. And then you have to substitute. So we are getting this particular formula, which is very, very important. And students, remember, this is for drop, liquid drop. Okay. If it is for bubble, if it is soap bubble, of course, it will have 2 surface areas. So we are going to just add one more formula in this case, students, and that is this particular part. This is for the, we can say, bubble. Okay. So whenever bubble part is there, that is having what? 2 surface areas. So it is 4T upon R, and if it is drop, it is 2T upon R. So of course, it is easy to remember. Then comes the capillary action. Capillary action is a very important concept, students. We have seen that when you put a wick, okay, in the oil, initially wick is dry, and after some time you can see that the wick is what? Completely oiled, because of the capillary action that has happened. Okay, so like that many more concepts are there. So you can just see the example over here. Oil rises in the wick of the lamp, cloth rag sucks water, right? So all these options are there. All these examples are which is given here. Then comes the capillary fall and capillary rise. Okay, these two concepts are there, because capillary action is based on what? Rise or fall in the capillary tube. Okay, so what is the action part? You have to remember why rise is there, why fall is there. This is based on this particular part. So you have to learn these two, students, these two things here. Maybe 2 marks question can be asked. Okay, explain the reason why there is a capillary rise, or explain the reason why there is a capillary fall. Okay, so you have to learn this particular part. So again, here in this case, based on rise or fall, this is a very important formula we are going to get. That is the height of the rise okay, is equal to what? 2t cos theta upon r rho g. Now, in this case, theta is nothing but what? Angle of contact, okay, angle of contact. And of course, T is the tension and R is the radius of this particular part, okay, radius of the capillary tube, and then density and G. So, depending on the liquid density, the height of the rise or fall will depend, okay. Then after this next part, so this is all about surface tension part, okay. So, we have completed surface tension. Now, the last part is about the fluids in motion, because till now we have studied what? When the fluids are at rest, that is what is the surface tension is produced here. Now, what happens when the fluid is in motion? So, students, when fluid is in motion, different concepts we are going to study about, that is about hydrodynamics. Okay, so these two things you have to study about, that is streamline flow and turbulent flow. Simple example I will give you for the streamline flow. Suppose you open a tap slowly. When you open tap slowly, what happens? The waterfall will be in a straight column like this. Okay, now the same thing when you increase the speed of the tap, or you increase the open it more, what will happen? The speed will be somewhat like this. Okay, this is called as the streamline flow and this is called as the turbulent flow. Okay, turbulent flow, what is happening? The speed of the water molecule is more than the critical value. Okay, and of course streamline flow, it is what? Less than the critical value. So, this is all you have to learn about. This is the streamline and maybe differences will be asked based on that. And then comes the critical velocity and Reynolds number. Just a definition part, Reynolds number, definition you have to learn about here. Okay, critical velocity, as I told you, the flow of liquid, okay, whether streamline or turbulent, if differentiated on the basis of speed of flow, which we call it as what? Critical velocity. And now we will talk about Reynolds number. Reynolds number, that is critical velocity formula is given in terms of Reynolds number, that is Vc is equal to Rn eta upon rho d. So, all these meanings are given here, students. So, we can find out Reynolds number based on that, knowing the critical velocity. So, this is all about you have to learn in this case. Then comes a very important one is the viscosity. Like for solid, we have learned the friction part, students, which was there in the 11th standard. So, here we are going to talk about viscosity. Okay. So, viscosity is very important. Again, it is nothing but, what is the viscosity? You must have seen that when you flow glycerin on the floor. Okay. Glycerin will not flow very easily as compared to water. Why it will not flow? Because one layer of the glycerin opposes the next layer of that glycerin. Okay. So, that opposition, force of opposition, we call it as what? Viscosity. That is the concept here. Then based on that, so viscosity definition we should learn here, and then based on this we are going to talk about, this is what the definition part which is given here, students. Okay, this is the definition part which is given here, and then velocity gradient, this is again definition for part. You have to learn about velocity gradient, that is the ratio of change in velocity to the change in distance which is measured. Okay, then a very important part is coefficient of viscosity, which is denoted by what? Eta. Eta is nothing but a coefficient of viscosity, and that you get because of Newton has explained about this, that is Newton's law of viscosity, students here. So, Newton says that the force of viscosity, that is a viscous force, is directly proportional to area and velocity gradient. So, if you apply the constant here, that is what is the coefficient of viscosity. So, you get this particular formula, coefficient of viscosity. Based on this, again coefficient of viscosity you should learn about definition part, and these definitions we can make it from the formula. So, do not have to by heart everything. Okay. And then after definition of viscosity, students, we have to learn about next part as Stokes law. Again, Stokes is the next scientist who explained about viscous force and all that. He said that if you in a glycerine, if you take a spherical body, this is all the glycerine because it is having good viscous force. Okay, and if you take a solid body in that, you drop it. So, solid body will not go very fast deep inside because the viscous layers will always keep on opposing the flow of sphere. Okay, that is what is explained by the scientist Stokes law. That is what is explained here. So, he said why it opposes and by what value it opposes, and that is given by this particular part. That is the viscous force is directly proportional to coefficient of viscosity, that is eta. Okay, eta, radius of the sphere, and speed of, that is terminal velocity of the sphere, okay, body which is dropped into that. So here constant is removed, we have to write the constant here students. So that is what is 6 pi is the constant which has been calculated with number of experiments, and they got this particular formula. So this is again the very important formula. Numericals of course is very simple based on this. 2 marks numericals can be asked. So terminal velocity students, I told you terminal velocity, this is the particular part. So terminal velocity questions derivation can be asked here. So this is all the derivation for terminal velocity. Now look into this particular diagram is very simple, which is represented here. There is a beaker, inside there is a water which is given here. So of course on the spherical body what all forces will act, weight of the body will act downward, that is mg will act downward, and there will be upthrust force which will be acting upward, okay, and of course upward force, two forces will be there, that is the upthrust force and viscous force. So we are going to just add those things. So this is what is explained here. So total downward force will be equal to total upward force. So downward force and upward force, this is what is the downward force, that is the volume of the sphere, that is 4 by 3 pi r cube, okay, volume, and density into g, that is mg part, okay, which we have written here, right. And then comes the Stokes law, who had explained about the viscous force which is acting, and upthrust force is this part. So after adding everything students, finally you are going to get the terminal velocity as 2 by 9 r square g bracket rho minus sigma upon eta, okay. So rho and the sigma, it is explained here, you should know the meaning of it. Sigma is the coefficient of viscosity, okay, and these are the densities of coefficient of viscosity, okay. Then after all this formula, this is a very important one, that is the coefficient of viscosity, formula is given, of course numericals will be based on that. And then comes at the end is the equation of continuity students, equation of continuity. Of course just learn a little bit of it, that will be more than sufficient for you to have it. So here in this case this particular formula we can learn, that is AV, that is the volume of volume rate of the flow of the fluid is equal to dV by dt. Remember this particular part, okay, and remember about the mass flux and volume flux. Just learn the meaning of these two things, that will be more than sufficient, okay. Then comes the Bernoulli's equation. Bernoulli's equation was a formula, you learn about it, okay. Bernoulli's equation formula is given finally as, in this case, this particular part, this is the Bernoulli's principle formula students, okay. So learn the statement and formula. Final expression of course is given here, okay. So P plus half rho V square plus rho GH is equal to constant. This is the Bernoulli's principle, okay. So definite statement and principle you just learn about it, and then comes the application, speed of efflux, okay, and Venturi tube. These two things, if you are not very much comfortable also, it is okay, but at least if you can remember the final answer based on that, okay, efflux. This is also easy one, but at least just go through once. If you are not able to understand completely, then slightly we will have to write it and explain it to you. So students, speed of efflux, Venturi tube and all these things we can learn here, but again let me just tell you, this particular topic is delete for this particular year, but still if you want to know more about it, you can put it in the comment, okay, because from continuity part it has been deleted, okay. Bernoulli's equation, this particular part has been deleted for this particular year, okay. So that means this particular part still is not there for this particular year. So students, anything if you want to know more about it, or derivation or something you want to learn, you can just put it in the comment, we will definitely help you out. Again, this particular topic we have done based on the demand of students, and I hope you have understood this particular concept, okay. So very small chapter, you should not omit this particular chapter as a very important one, and you can definitely score very good marks in this, okay. So wish you good luck students, thank you.